Hello, my name is Natalia and I'm going to explain topic 3, that is scalar and vector quantities. So, some quantities can be only specified by its magnitude, which is a number, and a unit. These quantities are called scalar quantities. They include distance, that can be 12 kilometers, speed, that can be 15 miles an hour, and volume, that can be 20 cubic centimeters. These quantities can be added and subtracted easily with algebra. We also have vector quantities. Vectorial quantities include displacement, that can be 20 meters north, force, that can be 50 newtons at 135 degrees, and velocity, that can be 80 miles an hour at 30 degrees north. To represent the variable as a vector quantity, we use a little arrow above the variables. Vector quantities cannot, I repeat, cannot be added or subtracted algebraically. A vector is a graphical representation of a vector quantity, represented by an arrow where its length points out the magnitude and the tip points the direction. To draw a vector, we should pick a scale that helps us represent its magnitude. The scale can be 1 on 1. So for example, if you have force that is equal to 5 newtons east, and the scale is 1 newton equals 1 centimeter, you can have a 5 centimeter arrow. It is important to learn how to show scales mathematically in order to be sure of your results. For example, if you have a force that is equal to 50 newtons west, and the scale is 10 newtons equals 1 centimeter, you can go 10 newtons over 1 centimeter, it's equal to 50 newtons over x. It's a simple rule of 3. So you go x centimeters equals to 50 newtons over 10 newtons times 1 centimeter. So you can say x equals to 5 centimeters. With this method, you can use more complex scales if needed. To show the direction of a vector graphically, we can use cardinal points or degrees. But if you're using degrees, make sure you're working counterclockwise, working from the right to left. We can also use both degrees and cardinal points. For example, 30 meters, 30 degrees north of west, which means a vector that is 30 degrees to the north, starting from the west. For any vector magnitude, we use r, and for direction, we use theta. We can obtain its components along the x and y axis. But for this, we need to use formulas. As you can see, for the x-axis, we go r cosine of theta, and for the y-axis, we go r sine of theta. So for example, if we have the vector f equals to 200 newtons at 60 degrees, we can obtain its components for each axis using the formulas. So we go 200 cosine of 60 degrees equals to 100 newtons, and 200 sine of 60 degrees, it's equal to 173.2 newtons. For the whole thing that matters, you have to know your quadrants. So this is angle 1 or A, 2 or B, 3 or C, and 4 or D. You always use Roman numerals. We also have to know the angles: 0 degrees, 90 degrees, 180 degrees, 270 degrees, and over here obviously goes the 300s, but because this is 0 and 360, we already know that.